Okay, Assalamualaikum warahmatullahi wabarakatuh. So, in this video, I will tell you about one of my idea, which is space computing. Space computing beyond the cloud. So, we have the thermal crisis destroying our planet's data infrastructure, demands and it demands a radical solution. So, this research argue that the next paradigm is not the edge, it's not the cloud, it's the orbit, it's space. A planet overheating its own mind. Modern digital civilizations runs on data centers, and data centers are increasingly consuming planetary scale energy just to stay cool, at the expense of electricity grids, freshwater reserves, and the climate itself. In 2025, data centers consume 485 terawatt hour electricity globally. 30% of that, more than the entire annual power consumption of Sweden, went purely to cooling. Source: this is DC consumption from 2024, 2025, 2030 projected almost 1000 terawatt hour. Share going to cooling is around 30 to 40%. This is the share of national grid. Water consumption crisis. Okay, it uses water, right? Global average power usage effectiveness is stagnated between 1.55 and 1.59. Why conventional solutions are running out? Air cooling is work up roughly 10 to 20 kilowatt per rack, and GPU clusters need 4 to 100 kilowatt per rack. Liquid cooling, direct to chip, and immersion cooling dramatically improve the heat transfer, but require massive water infrastructure. Free air or geothermal. Also, demand for AI compute cannot be concentrated entirely in Iceland or Norway. Underwater data centers. Microsoft Project Natick proved technical viability but discontinued in 2024. The sealed modular design can be upgraded, repaired, or expanded to meet AI demand when computing needs to be cooler than space. Yeah, it's about the quantum computing. The temperature cascade require dilution refrigerator using a mixture of helium-3 and helium-4 isotope. Each state requires separate cooling infrastructure. And then, room temperature is 300 Kelvin. Liquid nitrogen stage is 77 Kelvin. Liquid helium pre-cool is 4K. Helium-3 is 1K. Dilution stage is 50K. And qubit operating temperature is 10 to 20 milli-K. Even outer space is 2.7K. The machine that cools the machine. So if you look into the quantum computers, the quantum chip is only that small on the bottom, and the rest is the cooling. So it's called dilution refrigerator. A single unit can cost between 500,000 to 3 million US dollars and takes days to cool down. And pulse tube cyro cooler, vacuum canister stages, and then when it comes to quantum computing, all forces of physics conspiring against the qubits. Even inside a dilution refrigerator with 515 millikelvin, qubits are under relentless assault from every physical interaction of the universe permit. The collapse of quantum superposition into classical states can be triggered by disturbance measured in femtojoules. Every branch of physics contributes a threat: thermal noise, electromagnetic interference, cosmic radiation, phonon vibration, charge noise, flux noise, background radiation, quasi-particle poisoning. And then this is the chart. The orbital paradigm, not cloud, it's a cosmos. Space computing is not an extension of cloud infrastructure, It is a categorically imagining of where computation will live. Why space solve cooling problem? Misconception: space is cold, so cooling is easy. Cosmic microwave background temperature is 2.7 Kelvin. Absolute zero, but space is a vacuum. With a medium, heat can only live by thermal radiation. A single H100 GPU generates approximately 700 watt. To radiate, it's an operating temperature of 50 degrees Celsius requires roughly 1 square meter of radiator surface. In reality, radiation is still better than anything on Earth. Passive superconducting cooling, space-only physics. Space computing advantage: a comprehensive view, unlimited solar energy, zero water consumption, land and permitting freedom, microgravity qubit isolation, reduced cosmic ray flux paradox, urban heat island elimination. This is the milestone. Yeah, and then this is the visibility. Key players is Star Cloud, SpaceX, Google Project Suncatcher, Jeff Bezos Blue Origin, Cowboy Space, and Lone Star Data Holdings. Well, a vision of Indonesian space infrastructure. Indonesia sits at the equator, one of the most strategically advantageous positions on Earth. For space launch, the equatorial boost for orbital insertion reduce the fuel requirement. The archipelago's digital sovereignty aspirations and rapidly growing AI infrastructure demand make space computing a distant abstraction, but a near, not a distant abstraction, but a near-term strategic imperative. This is me. Yeah. Okay, and okay. I think that's all, guys. Thank you.